Wir schreiten einen Schritt weiter und zwar, jetzt wird es richtig interessant. Kommunikation steht im Zentrum des heutigen Tages, aber wir sprechen jetzt über Kommunikation bis und mit in den Weltraum hinein. Ein faszinierendes Thema. Wir dürfen eine faszinierende Firma kennenlernen und ich habe mir eigentlich vorgenommen, den Namen, die Aussprache des Namens zuerst noch zu besprechen mit Ihnen. Das ist nämlich, wenn ich mich nicht täusche, ein niederländischer Name, also Emile de Rijk. Habe ich das einigermaßen richtig gesagt? Guten Tag und herzlich willkommen. Sie sind der CEO und Gründer von Swiss 212. Das ist ein Spin-off der EPFL. Das gehört zu den WEF Top 100 Pioneers. Was ist Swiss 212? Ein schnell wachsendes Raumfahrtunternehmen, also ein prickelndes Thema. Und mehr von Ihnen hören wir jetzt. Ich freue mich sehr darauf. Emile de Rijk.
Dankeschön. Good, so if you don't mind, I'll deliver the speech in English for ease for everybody. So my name is Emile de Rijk, I'm the founder and the CEO of Swiss 212. We're a company based out of Renan, close to Lausanne, with an expertise in radio frequency systems that over time we have developed into becoming a satellite manufacturer for some of the leading telecommunication operators worldwide who operate satellites that we build to connect people across the globe, across various applications. So maybe to put this into context, what we are used to in Switzerland is to have an excellent telecommunication infrastructure, one of the best in the world. But this is an infrastructure that is predominantly relying on ground systems, so fiber optic networks, mobile telephony networks, point-to-point communication based on ground infrastructure, which is, of course, a great way to connect the many in our country in a very performing way, but it's also an architecture that has a certain number of vulnerabilities from an infrastructure point of view, from a reliance on foreign manufacturers' point of view. And so having a component of connectivity through space for a country is something that makes sense to increase the resilience of the network and be able to counter any situation. So it's a bit uncommon to have this in your country, but we have the capability to build telecommunication satellites in Switzerland. We're the first company to do this end-to-end. So headquartered out of Switzerland, we have sites in the US and in various European countries, and we've developed over time into the various specialties that are needed to architect, build, and test telecommunication satellites that can deliver connectivity out of space. Today we have a bit more than 150 people. We are backed by Swiss and European investors, amongst others Swisscom and Swisscanto and Zürcher Kantonalbank. So a Swiss company with a sovereign Swiss ownership structure. So what is so special about what we do? We build what's called HummingSat. HummingSat is the small satellite on the right-hand side, which you can compare to traditional, much larger satellites that are built by the established players in this industry. So today, most of the satellites that relay data in space and support telecommunications are built by large aerospace companies like Airbus, Boeing, Thales, Northrop Grumman, Lockheed Martin, names like that. And there is an emergence since about 10 years in this industry of the so-called new space wave, with new, smaller companies being able to propose products and services in a credible way in this market. And we are the first ones to penetrate the so-called geostationary satellite market with the HummingSat product, which is a much smaller satellite, makes it much more affordable per unit. And that means it becomes a credible investment for regional operators, for small and medium-sized nations who want to have a sovereign connectivity solution and still have a competing solution that they can rely on competitively. So what can you do over a satellite? Of course, it doesn't really make sense to connect one side of Bern to the other side of Bern with a satellite. You're much better off laying a fiber, and this will be a much faster and lower cost connectivity service. But there are plenty of scenarios where this is not possible, and where connectivity over satellite becomes a competitive solution, be it for remote locations, to connect platforms on the move, so planes, ships, vehicles, emergency services, to provide highly secure data links that are inherently difficult to hack. You have to imagine that you beam a signal up from the ground to a satellite, and then from the satellite to the customer or user of the service. If you want to intercept that signal, you need to be positioned more or less along that path with a big antenna to listen and intercept the signals, which is obviously something that is not very discreet to do. So a quick retrospective about our history. So we are a spin-off from the École Polytechnique de Lausanne, EPFL, where we started in 2011. We were originally specialists in building some of the antennas that go into satellites. We were the first ones to develop a 3D printing technology to build these antennas more competitively than the state of the art. And with that technological brick, we grew around it into making the entire telecommunication systems of satellites, and then eventually making entire satellites with HummingSat recently. So a few milestones along the way. We were very much supported by the European Space Agency since 2015, working our way up the industry value chain, putting our first products in space in 2011. Then signing a major partnership with the European Space Agency to allow us to become a complete satellite manufacturer with their support, financial and operational, in 2022. And then two very important milestones for us were the order of a first satellite from Intelsat. Intelsat is the largest satellite operator delivering telecommunication services out of space. It's also the oldest satellite operator in the industry, so an excellent anchor customer to start with for us, and which was followed by an order of 3 more satellites by Viasat Inmarsat. Inmarsat is a world leader in mobile connectivity over satellites, so connecting a large portion of the ships at sea, of the airplanes in flight, and other mobile platforms along the way. And we have our first launch in 2026, so it will be launched on an Ariane 6 out of Kourou in French Guiana. The Intelsat satellite will go up. Shortly after that, the Inmarsat satellites will go up. And we're, of course, working now on new opportunities to have a constant flow of production of telecom satellites out of Renan in Switzerland. So maybe for those who are not familiar with the terminologies of orbits and types of satellites, obviously with the news, a lot of media attention is given on the satellite constellations, predominantly the SpaceX satellite constellations. These are satellites that fly very close to the Earth in so-called low Earth orbit. It has a certain number of advantages in the sense that the round-trip time of a signal is very short. It takes about 50 milliseconds. It's called latency. It's what's critical for users who are working on time-critical applications, such as banking, gaming, or other types of applications. But it has the disadvantage that the satellites are so close to the Earth that they revolve around the Earth much faster than the Earth revolves around itself. And so you need a grid of thousands of satellites flying in precise orbits, such that at any point in time you have one above your head that you can connect to and hand over to the next one when the previous one has left, etc., etc. So it's an extremely capital-intensive way of connecting people through space. So actually the industry 60 years ago, when the first satellites were put up in space to deliver connectivity, were put into what's called the geostationary orbit. This is an orbit that lies on the equator of the Earth, and it's relatively far. It's at 36,000 kilometers above the Earth, but it has a beautiful property, which is that if you put a satellite there, it will orbit the Earth at the exact same speed as the Earth revolves around itself. Thereby, a satellite is a fixed position in the sky, which means you can buy a 10 Swiss franc parabola dish, go to your roof, point it to the satellites, tighten the nuts, and be connected for decades without having to invest much into the ground infrastructure. And with a satellite that can cover a third of the Earth at once and really have a wide field of view and monetize on the assets. So fundamentally, geostationary satellites remain the cheapest way to connect users on the ground if you purely look at figures of merits like dollars per megabit per second per month. So maybe if we go at the use cases for a smaller sized geostationary satellites, like the one we're developing at Swiss 212, we're predominantly focused on regional missions, so missions where buying a very large, very expensive satellite from a big player actually does not provide return on investment in a good way for the operators who want to monetize on the asset. And so we're essentially cutting the problem into smaller pieces and allowing operators to buy satellites of smaller size, of smaller price, in a more incremental fashion, allows them to position themselves on these regional markets. We also see a lot of demand for markets where you have a large satellite that provides connectivity over a large region, but you have certain hotspots that become too hot and essentially hinder the deliverance of complete service to users and can be complemented by smaller assets. There's also a theme around replacing aging broadcasting satellites. Although everybody now has internet at home and there's an emergence of streaming services, there is still a solid market base for video and content delivery over satellites worldwide, which will continue to exist for some decades to come. As well as secure connectivity satellites, so governmental-owned satellites or dual-use satellites, which are used to deliver secure connectivity to sovereign nation-states who want to have this as either an operational means or a backup infrastructure in case of cyber attacks, hacks, or instabilities. So I won't bore you with more technical details than this slide. Our HummingSat is about 1 ton, so you have to imagine it's a very large fridge of about 2 cubic meters. It can carry roughly 200 kilograms of hardware into space, which is the payload. So that's all of the hardware that receives signals from the ground, processes them, amplifies them, sends them back to generate the data link to users. And it's a satellite that's operational for about 15 years in orbit. So you have to imagine that you tailor a mission for a certain geography, for a certain use case. You shoot it up into space, and then you have 15 years to amortize the asset out of orbit. Another important parameter here is the partnership with the European Space Agency. So it is very difficult to build a satellite, especially when you have to build everything and it has to work. So on top of working with expert partners and suppliers in this industry, and on top of recruiting a very large and multifunctional team that's able to do this, we're also getting excellent support from the European Space Agency, who have not only co-funded the development of this satellite product line, but also contributed with about 20 people of very broad expertise to help us execute against the development of these satellites. It's important to note that Switzerland is a founding member of the European Space Agency and very active in this organization, playing a big role since the beginning, and also helping a great deal with companies in Switzerland who want to develop a business and technologies for space. So Mary, very briefly, a little video. If it starts, it doesn't start. I give up. No. It was the end anyway, sorry. Thank you very much.
Please stay with me on the stage, maybe on that side if you want. And I'll see if we have gotten some questions from the audience. Just a moment until I'm online. Where are we? Here. Okay, we've got a couple of questions. And that's the questions in the first row. What role can satellite communication like Swiss 212 or Starlink play in Switzerland? Maybe I can add that I thought Albert Rösti mentioned the 750 millions that Switzerland wants to invest in fiber in remote areas. Is that the right goal?
Well, there is a limit until which it is worth putting money into fiber for remote locations, and there is a certain limit where it's no longer worth it. It's actually more economical to do it over satellites because the price of putting one satellite in orbit plus the marginal price of equipping the various remote users with ground equipment is going to be much lower than to dig the trenches to put the fiber in there for a very limited amount of users. So typically in Switzerland, it's probably in some tens of thousands of landing points that are more economical to service through space than through ground infrastructure.
Let's stay with Switzerland. The topology with our mountains, isn't LEO a better alternative than GEO to cover the white spots?
Depends what you want to do in terms of coverage. Of course, you can solve the problem technically with LEO. You will have the advantage of having a low latency. So that's a parameter approximately 30% of the users are sensitive to. But intrinsically, a LEO system has a cost disadvantage, so it's more expensive in short terms. And the other thing is the LEO connectivity solutions that are out there today are controlled by one billionaire and soon a second billionaire. And we've seen that decisions can be made to switch it on or off, or as it may please them. So when it's about commercial services, this is less of an issue. But when you have reliance for sovereignty reasons on those connectivity solutions, this can be a problem that the geosatellite can offer a solution to in terms of having a fully owned asset that you completely control. And
quite interesting. Sorry?
And that delivers in net, so let's say a lower cost of connectivity.
I would have some more questions, but we're running out of time, and I say thank you very much for this interesting insight.
Thank you.
Emile de Rijk. Thank you very much.
Thank you.